Hello and welcome back, my freaky physics students. This one we're going to do some component vector, or just one component vector problem. So let's say we got a couple of guys. Their names let's see, let's call him James, and let's call this guy Peter. Okay, those are good names. And let's say that both of these guys, they have to walk to school every day. And they don't like to walk to school because they got to walk to school through this path through the woods, and there's scary trees and like scary moss, and sometimes there's bears, and they've got big teeth and ears, and stuff like that. And so they say, you know what we should do? We should build, this is what Peter says to James. He says, you know, James, what if we just built this big slingshot, right? So they get this idea. We're going to build this big slingshot here at the beginning of the trail. And what we're going to do is we're going to strap you in it and pull it back and just shoot you over to where we need to go, instead of, walking through the woods with the scary trees and moss and stuff. And James says, oh, that's such a good idea, because it's so scary. I think that this would be so much better. And so anyways, so first of all, they have to figure out, well, what angle are they going to aim the slingshot at, and how far do they need to shoot it? So here's what they know. They know that, and let's say this is our grid, and this is north, this is east, and this is west. So they know that their trail goes 60 degrees west of north. So this would be 60 degrees west of north. And they know that that goes for 0.40 kilometers in that direction. And then the trail turns and they go due west for 0.50 kilometers before they get to their destination, right? So what they need to know is, what is the angle and what is the direction of this resultant vector right here, so that they can set up their slingshot to shoot themselves over here. And so they think this is a good idea. So they set about to figure this out. So what are they going to do? Well, the first thing they do is they decide, well, what we need to do is we need to figure out what all of our vectors are going in the x direction and what all of our vectors are in the y direction. Because if you take a look at this situation, this particular angle and length right here is the hypotenuse of this bigger triangle right here. And so really what we want to do is we want to say, what are all of our x vectors and what are all of our y vector components? So the x vector components are going to equal this one plus this one. So we're going to have that 0.50 kilometers in the x direction, which is west, and we'll call west positive in this case, plus we need to figure out what is this component, because this angle, this 60 degree west of north angle, it has both, it has you both walking in the west direction and in the north direction, right? So it has, if you took this angle, what we do, we want, instead of having this angle, we want to break it up into two directions, a north and a west, and separate those two, so that we can figure out essentially all the sides of this triangle, so we can figure out the hypotenuse here of this triangle, which would be the resultant vector. So let's go ahead and just start right here. So here's my triangle right here, and this is 60 degrees, and I know that this right here, which makes the hypotenuse of this triangle, is 0.4 kilometers. So what I could do is I could use my trig function, SOH, which means the sine of the angle theta equals the opposite over the hypotenuse. So what I would say is, and I could just, I'll just do this right here. So the sine of my angle theta, which in this case my angle theta is 60 degrees, right? So the sine of 60 degrees equals, let's call this x, XA, and then this one could be XB, but we know what XB is and we already wrote it in. So this is x direction vector A. So let's say XA, because that's the opposite, and so the opposite side from the angle theta right here, over the hypotenuse. We know the hypotenuse is 0.40, right? So then all we have to do is multiply the sine of 60 times 0.40. And if you do that, you should come out with, let's see, what did I get here? 0.346, so let's say 0.35. So 0.35 kilometers. And I add that together, and that's going to give me a total of 0.85, sorry about that, 0.85 kilometers in the x direction. Now I got to figure out the y direction. Well, when I look at this, this is all x direction here, has no y component to it. This one has a y component and an x component. So what I'm looking for is this part of this triangle right here. So I could use the trig function KAH. So this is my just typical SOHCAHTOA trig functions, right? And so if you don't know those, so and then ka, toa, should be able to get you most of the answers if you have an angle on one side. Really easy to figure out. So this is the sine of the angle theta equals opposite over hypotenuse. Cosine of angle theta equals adjacent over hypotenuse. And then the tangent of angle theta equals opposite over adjacent. So now all I need to know is I'm going to use cos. So the cosine, right, of 60 degrees equals the adjacent. That's the one that I need to know, this y direction here. And let's call this the vector YA over the hypotenuse, which is 0.4. So if I multiply that out, I will get that equals 0.2. So in the y direction, I have 0.2 kilometers. Okay. So now, how do I resolve this vector? Well, now it's as simple as Pythagorean theorem, because I know that my total x direction is 0.85 and my total y direction is 0.2. So my resultant vector, r squared, is going to equal 2 squared plus, I'm sorry, not 2, 0.2 squared plus 0.85 squared, which is going to give me something. I'll take the square root of it, the whole thing, and I'll just do that in my calculator right now, and I should get 0.87 kilometers. So that tells me the length. So they know they need to slingshot themselves 0.87 kilometers. Okay? So that should be easy enough. So 0.87 kilometers is going to be a big slingshot, and they're probably going to die at the end, but they haven't thought that through yet. And maybe they won't, because both of these guys are really, really tough. You know, maybe the worst they could do is like break their hand or something, or the wrist, you know. So we have 0.87 kilometers, and what is this angle right here? Well, to figure out the angle, if you have information like this, it's a pretty simple formula. So you could take the inverse tangent, and essentially all you're using is this trig function here. You could take the inverse tangent, so we'd say tangent -1 of all your components in the x direction, so your x direction components divided by your y direction components, right? So that's all you got to do, and this will always give you the angle that you're looking for right here. And so in this case, it's going to be this angle right here, right? So you'd want to make sure to define that correctly. So this angle right here can be calculated as part of this trig function and just the inverse of it, which would be the inverse tangent of the x over the y. So if I take the inverse tangent of the x, which is 0.85, right, divided by 0.2, I get 77 degrees. So 77 degrees, we need to define that. This would be west of north. So west of north. So 77 degrees west of north. There it is. So now they know their angle, and now they know their distance they need for their slingshot, so they're ready to go, and they should be able to slingshot themselves right to their destination. and avoid all the scary wilderness and moss and stuff. All right.